أنا من علك اقرأ وربك الأكرم الذي علم بالقلم علم الإنسان ما لم يعلم كلا إن الإنسان ليطغى أن رآه استغنى إن إلى ربك الرجعى صدق الله العظيم.
Translation. In the name of Allah, the most gracious and the most merciful. Read, in the name of your Lord who created man from a cloth of congealed blood. Read, and your Lord is most generous, who taught by the pen, taught man what he did not know.
Ladies and gentlemen, it is our pleasure to give you an overview of the Institute before we proceed with the conference. KIET is a degree awarding higher education institute chartered by the Government of Sindh and approved by Higher Education Commission, Government of Pakistan. The institute has 4 colleges with degree programs.
The College of Engineering, approved by PEC, has Bachelors of Electrical Engineering, Mechatronics Engineering, Avionics Engineering, Software Engineering programs, MS and PhD programs in Electronic Engineering.
The College of Management Sciences offers BBA, BS ERP, BS Accounting and Finance, MBA, MS, MPhil, and PhD programs.
The College of Computing and Information Sciences offers BS, Computer Sciences, BS Telecom and Networking, MS and PhD programs in Computer Sciences.
The College of Media and Arts offers Bachelor's and Master's in Computer Arts and BS in TV and Film Production.
The Institute has 3 campuses. The main campus, where both undergraduate and graduate programs are conducted. The City campus, located at Sharai Faisal, where Computer Science program, Management Science program, and Media and Arts program is conducted.
And the North Campus at North Nazmabad, which conducts both morning and evening programs in Computer and Management Sciences. I feel more than privileged now to invite upon the stage President KIET, Air Vice Marshal Usaidur Rahman Usmani, Sitare Imtiaz Military, for his inaugural address.
Bismillahirrahmanirrahim. Honorable Chief Guest, Dr. Ishrat Hussain, former Governor, State Bank of Pakistan, the representative of IEEE, Higher Education Commission, the reps from Pakistan Air Force, Pakistan Education Foundation, worthy national and international speakers, including Dr. Waleed Ejaz from Lakehead University, Canada, virtual participation from Dr. Nagam Saeed from University of West London, Dr. Lubna Lakshmi from University of Limerick, Ireland, and Dr. Sama Alexakir from University of West London again. Distinguished guests, ladies and gentlemen, dear students, Assalamu alaikum. It gives me immense pleasure to welcome you all on this 11th international conference being conducted at Karachi Institute of Economics and Technology. This conference, which opens today, is the 3rd international conference organized by the College of Engineering itself, which aims to provide a platform for researchers within Pakistan and abroad to share their intellectual work and receive feedback from like-minded people. It also endeavors to act as a bridge between academia and industry as it brings together researchers, faculty members, consultants, and industry experts at one platform. Right at the outset, I wish to profoundly thank all our international and national speakers who would be participating in the conference and would be sharing useful knowledge through their talks. Ladies and gentlemen, KIET, a collaboration between Pakistan Air Force and Pakistan Education Foundation, was established in year 2000 as a higher education institution in the private sector. And today we operate from 3 different locations across Karachi, and currently about 4,000 students are pursuing various degree programs at the institute in the fields of computing and information sciences, management sciences, engineering, humanities, and media and arts. Alongside with a faculty strength of about 300, the institution has been contributing meaningfully towards the overall improvement of society. So there is no denying the fact that the research and development is an ongoing process. At the global level, it can be seen that all those countries where this aspect is given due importance, they progress substantially. Therefore, it's an extremely important thing for a country like ours to invest in research and do our utmost to create an environment for research and development to flourish. On the other hand, researchers need to focus on relevant fields and bring home intelligent ideas, pragmatic solutions to contemporary problems, and inventions so as to first meet the local and regional challenges. In recent years, KIET has made humble efforts to contribute to this important task. Our competent team of researchers is constantly involved in various applied research activities, and we are proud to share that the PhDs at this College of Engineering and other colleges are indeed doing some amazing work which has been acknowledged at the international and national level. Publication of 3 research journals, namely Technology Forces, Market Forces, and KIET Journal of Computing and Information Sciences, conducting of 11 international conferences in just last 6 years, and receiving to date a healthy amount of grant of almost rupees 200 million, which includes a record 75 million in just last year, and highest ever journal publications of 76 with cumulative impact factor of over 123 in the current year, are some notable contributions by KIET in the realm of R&D. KIET students' achievements in various international and national robotics and electronic competitions are also reflective of the vibrant research ecosystem at the institute. Today, within an overall healthy strength of 30 PhD faculty, we undertake to keep up the tempo and bolster research-oriented efforts while alongside pursuing efforts to provide quality education for all programs. Furthermore, official recognition of AURIC at KIET by HEC is also expected to further facilitate the outcome of research activities being undertaken by our faculty and students while linking KIET with the industry through important MOUs. All said and done, despite of many challenges, KIET has in a very short span of time made an impressive mark in R&D, and I take pride in mentioning that the institute leads all private sector HEIs in SIN in this domain. Concluding, I wish to thank our international speaker, Dr. Walid Ejaz from Canada, who is here with us in person, and all those who would be joining us and participating virtually from UK and Ireland. And I would also like to thank our national keynote speakers, as well as all other participants who have come forward to participate in the conference. I do hope that all participants and the audience find these 2 days interesting and productive. As far as this conference is concerned, I would like to take this opportunity to appreciate the extensive effort undertaken by the Intellect team led by Dr. Samir, and I wish them very best of luck in the successful conduct of the conference. My gratitude is also due to IEEE for providing us the unique opportunity to conduct conference from this platform. In the end, I once again profoundly thank our chief guest, sir, for sparing your valuable time coming all the way. And despite of your hectic schedule for the month and small health concern, I'm really from depth of my heart grateful for you being here, and it's a source of great encouragement for us in the faculty and for definitely for the students present here. I hope that all participants find these 2 days fascinating and high yielding. I thank you very much.
Thank you very much, sir. Ladies and gentlemen, now we would like to invite the conference chair, Dr. Samir Qazi, to kindly come on the stage and give a brief introduction of the conference. Ladies and gentlemen, please welcome the conference chair, Dr. Samir Qazi.
Okay, Bismillahirrahmanirrahim. Respective Chief Guest Dr. Ishrat Hussain, former Governor State Bank, President KIET, Dean Academics, Registrar, Director College of Engineering, Directors of other colleges, IEEE Vice Chair, Karachi Section, our technical co-sponsors for this conference, our esteemed international and national speakers, guests, participants, faculty members, staff members, students, and our other honorable guests from the Pakistan Education Foundation, members of the Pakistan Air Force. I warmly welcome you all to the opening ceremony of the conference, and I thank the President for appreciating the efforts of the College of Engineering in holding this international conference for the 3rd time in the last 5 years. Alhamdulillah, it gives me great pride today to see the College of Engineering research conference journey that began in 2017 resume again with full vigor after a brief hiatus due to the COVID-19. This year, Intellect 2022 received 72 submissions in all in the technical tracks of microelectronics, control and automation, communication and networking, information processing, embedded systems, and software engineering. These 72 submissions underwent strict plagiarism and quality checks as mandated by the IEEE Karachi section and IEEE USA. After the quality checks, rigorous peer review by PhD qualified faculty members from both national renowned HEIs of Pakistan as well as international technical program committee members. Finally, 23 submissions were selected for oral presentation in the conference. So this means a 32% acceptance rate, which is within the mandated IEEE rules and regulations. The authors of the accepted papers are affiliated with all top HEIs within Pakistan, as well as we had a few submissions from international authors. Besides these oral research paper presentations, Intellect will have several other collocated activities in the form of tech startup competition and several workshops. Brief rundown of the conference activities today. Detailed programs will be provided in the author kits being provided by our committee members, and they are also placed on the notice boards inside the College of Engineering building. In this opening ceremony, there will be 4 technical talks on cutting-edge state-of-the-art research topics being carried out nationally and internationally. I once again thank our international plenary speaker who is in person today, who has come all the way from Canada to be with us, and we hope to benefit from your worthy talk. And I'm also very happy, 2 of our very own professors from KIET, they will also be presenting their cutting-edge research work in this conference over the 2 days. There will be 3 technical sessions after this opening ceremony, and there will be 2 workshop sessions which will be conducted concurrently after the opening ceremony. Our committee members of the organization committee will guide the participants. Day 2 of the conference will resume tomorrow. Day 2 will commence with the technical paper presentations in the morning. The closing ceremony of the conference will commence tomorrow in the afternoon with plenary sessions, again having 4 technical talks on the latest and most relevant research topics. The conference will finally conclude with the award distribution ceremony. In the end, I will again thank the support of all higher management of KIET and the guidance of the IEEE Karachi section in guiding us through all the crucial stages of the conference, like always. Last but not the least, the conference would not have been possible without the excellent teamwork put in by our organizing committee members. So I sincerely wish to thank all the members of the organizing committee, having members from faculty, staff, and students who had put in relentless efforts in putting all this together. I sincerely hope that all the participants will have a memorable time at Intellect 2022. Thank you.
Thank you very much, sir. Ladies and gentlemen, Intellect 2022 is technically co-sponsored by IEEE Karachi section. The aim of this conference is to bring together researchers, scientists, and representatives of industry to discuss the latest directions of research in engineering technologies, identify solutions to current national problems through industry-academia collaboration, and to contribute in nation building. Let us now proceed with the conference brief by IEEE Vice Chair of Karachi section, Dr. Tariq Rahim Sumro. He is currently serving as an acting rector and is a former dean of College of Computer Science and Information Systems at Institute of Business Management. He did his PhD in computer applications from Xinjiang University, Hangzhou, China. He has substantial and diverse experience in the field of computer science over more than 28 years. He has established over 100 peer-reviewed papers. He is a senior member of IEEE since 2005 and IEEE member since 2000. He is currently serving as Vice Chair, IEEE Karachi section and IEEE Computer Society. He is also IEEE Computer Society Distinguished Visitor 2021 till 2023 and recently became the first Pakistani to be selected by IEEE Computer Society to the inaugural class of IEEE Computer Society Distinguished Contributors. Please welcome Dr. Tariq Rahim Sumro.
Assalamu alaikum, Honorable Chief Guest, dear colleagues, researchers, students, assalamu alaikum again. On behalf of Chair IEEE Karachi section and Executive Committee Karachi section, I'm thankful to you for joining third International Conference on Latest Trends and Electrical Engineering and Computing Technologies, Intellect 2022. Here, I would like to mention that IEEE is the world's largest technical professional organization dedicated to advancing technology for the benefit of humanity. IEEE and its members inspire global community through its highly cited publication conferences, technology standards, and professional and educational activities. There are few glimpses of the IEEE. 409,000 members all over the world with 160 countries, 125,000 student members. We are in working in 10 regions, and in region 10, Karachi section is consist of whole Sindh and Balochistan province. It is not out of place to mention here that all the paper which were be uploaded on the, as Dr. Saab said, that's a 32% acceptance rate. So all the paper will be uploaded on the IEEE Explorer, and they will be, Scopus Index. And the Scopus Index is nowadays very important for the higher education institute, as QS ranking is only counting these Scopus Index things. IEEE Karachi section is in OU of IEEE Region 10 and IEEE Karachi section oversees technical societies. For example, chapter of Computer Society, Communication Society, Power and Energy Society. We have Industrial Electronics Society and one joint chapter of Robotics and Automation Society with our two neighboring section, Islamabad section and Lahore section. So total three sections are in Pakistan. We do have the affinity groups like YP, Young Professional, Women in Engineering, and a special interest group on humanitarian technology side. We have more than 20 student branches active throughout Sindh province and the Balochistan province. Also, want to mention here that we have two subsection now, Quetta subsection and Sakhar subsection. So we are growing, and our two section will, after a few years, they will become the full-fledged sections. So on footsteps of the IEEE Karachi section support quality conferences in various technological area that are recognized by the academia and industry. Articles submitted for publication follow a proper selection process and are peer reviewed, generally single blind review. And they are published in IEEE Explore. IEEE Karachi section provides the right forum for authors and speakers to present their work at various annual conferences, including today's conference, Intellect 2022 Karachi. Karachi section also provides its members and volunteers with networking and interaction opportunities through local meetings, events, and conferences. So what happened in this year, 2022, we organized, we supported technically 6 conferences. First was the International Conference on Emerging Trends and Smart Technology, September 2022, FAST, Karachi. The third, Muhammad Ali Jinnah International Conference on Computing Magic, that was 27-28 October in Maju, Karachi. 14th International Conference on Mathematics, Actuarial Science, Computer Science, and Statistics, MAX 14, recently held at IOBM at our institute, 12 to 13 November. This is third International Conference on Latest Trends in Electrical Engineering and Computing Technologies, 16-17 November. Then 2 upcoming conferences are coming. International Conference on Emerging Technology on Electronics, Computing, and Communication at MUTE, December 7 to 9, Mehran University of Engineering and Technology. Third International Conference on Innovation in Computer Science and Software Engineering, ICONIC, December 14-16 at NED. And already we signed 2 MOUs for the 2023, and we are signing 1 MOU here today for the Computer Science Department for 2023. So already 2 MOU signed, 1 we are going to sign. At the end, on behalf of IEEE Karachi section, I will again assure you that we will support quality conferences and we will support you all the way. Our members were also part of the review committee, and our support is always with you. Thank you very much.
Thank you so much, sir, for your insightful views. Let us begin with the plenary talks of Intellect 2022. The Industrial Revolution is at its peak in the past few years, and researchers are extensively working to connect all electronic devices with each other. Dr. Walid Ijaz, our first speaker, will present his significant research on the Internet of Things. He is an assistant professor in the Department of Electrical Engineering at Lakehead University, Canada. He served as an assistant professor from 2018 to 2020 in Department of Engineering and Applied Sciences at Thomson Reuters University. Previously, he held academic and research positions at Ryerson University, Carleton University, and Queen's University in Canada. In 2014, he completed his PhD in Information and Communication Engineering from Sejong University, Republic of Korea. He has co-authored over 90 papers in prestigious journals and conferences with 3 books. His current research interests include Internet of Things, energy harvesting, 5G and beyond networks, and mobile edge computing. He is an associate editor of IEEE Communications Magazine, IEEE Canadian Journal of Electrical and Computer Engineering, and IEEE Access. Dr. Walid Ijaz is also a senior member of IEEE, member of ACM, and ACM Distinguished Speaker. Please welcome Dr. Walid Ijaz.
Thank you very much for introduction. And first of all, I would like to thank you, Keith, for having me here. So the topic of my talk today is enabling technologies for Internet of Things in 6G networks. Okay, so I'm skipping my introduction because thankfully she already introduced very well. Just quick overview that recently I have published one book on Internet of Things for smart cities, technologies, big data, and security perspective of that. Okay, so the outline of my talk today is, yeah, that would be helpful. Hello, hello. Hello, can you hear me? Okay. Okay, so this gives me. So I will go over the introduction of what Internet of Things is, then some requirements and then I will go over the enabling technologies in 6G networks. Overview of my research followed by. Okay, so let's first understand what is Internet of Things. So Internet of Things is intelligent connectivity of millions and billions of smart devices and sensors, right? So if you look at the current trend, only 1/3 of communication devices are over laptops, cellular networks, or you can say over. The rest of all are IoT devices, right? So basically, what we want is we want to make everything smart, right? For example, if we want to make smart refrigerator out of this smart city, so we can see here in a refrigerator, in order to make it smart, we need to equip this refrigerator with things. Number one is because we need to send something, then ability to compute, and then ability to transmit, right? So computing, sensing, and communication ability. So we want to empower our things to sense, reason, and communicate about the environment. Now, if we look at the IoT components one by one, so the first component is data generation. So data generation starts from physical space as well as cyberspace. So physical space means where we have physical sensors installed like GPS, like temperature sensors, humidity sensors, and all these physical sensors are involved. Whereas cyberspace, where we have social media applications which are continuously generating data. Now, when we have a bunch of amount of data which is generated by physical space as well as cyberspace, we need some computing facility as well, right? Just to give you an example, how much amount of data we are talking about these days is that sensors in one autonomous car can generate 4,000 gigabits of data per day. An Airbus A380 engine generates 1 petabyte of data on a flight from London to Singapore. So that means we are talking about a large amount of data. Now, once we have this large amount of data, what we need to do is we need to transmit this data to somewhere over the cloud in order to analyze this data and get some insight out of this data. So communication technologies are key components in the IoT context. For example, we have communication technologies which are low power and low range communication technologies, which include 3G, Bluetooth. We have low power, long range communication technologies like Sigfox, LoRa, And we have high power and long range communication technologies as well, like cellular network. Now, depending on the application which we are talking about, we can choose one of these technologies. And now that we generated a lot of data from physical sensor space and cyberspace, next thing is we have that data from the communication technology over the cloud. Now, next is to analyze that data. Now, the analysis of data could be descriptive. That means what happened, up to perspective analytics. That means what actions we need to take. Now, the thing is, the more we go in this direction, the more analytics we need to perform, the more strong, robust algorithms we will need, right? So in summary for Internet of Things, what we have is we have exponential increase in connected devices and data generation. We have a large amount of data generated. Then we need some communication technology to do the real-time transmission or non-real-time transmission to the cloud. And on the cloud, we want to analyze what is going on, right? Now, if we look at the implication of IoT on the city, right? So cities provide us the services and cities have infrastructure, right? So if we add a data layer, that means IoT layer in between the infrastructure and services. What does that mean? We can get insight from the infrastructure, how it is doing, and we can also get insight from the customer's point of view that what they are looking for, and we can provide better services to the customer, right? And this calls basically, if we add a data layer between services and infrastructure, this calls a smart city, right? This calls a smart city. Okay, challenges and requirements. So before going into the challenges and requirements, let's see where we are standing right now. We are discussing 5G, implementation of 5G in some areas of the world which already have 5G networks available. So there were three main things which are key in the 5G networks. First thing was ENBE, which means enhanced mobile broadband network, more data rate, higher data rate. And starting from first generation of cellular network until fourth generation of cellular network, the only target was the data, right? But in 5G, the difference was that we were targeting the data rate, better data rate. We were offering some machine type communication support. That means our network should be able to support a large number of devices, IoT devices, including that, which could be high density, and IoT devices are in general low power devices. So that means they need to be energy efficient as well. Whereas our traditional cellular networks, they are data hungry and they are power hungry as well. And the last thing we have in 5G is URLLC, which means ultra reliable low latency communication, right? So our goals are diverse in 5G network, and we have higher data rate, we have support of large number of devices with ultra reliable and low latency. On one side, we are talking about that very high data rates, very low latency, and very large number of devices. Whereas on the other side, we have basically a digital divide problem. If you look at this map of world, you can see the dark green colors are those countries which have very high connectivity, right? Whereas the light colors depicts the very low connectivity. That means connectivity is a big issue. So which means that we have a divided world. We have a digital divide, not only among the countries, but within countries. Just let me give some examples. From Canadian perspective, the government of Canada in 2017 said that every Canadian must have 50 Mbps download speed and 10 Mbps upload speed. We call it 50 by 10 objective. Until 2019, 85.7% Canadians do have this access. However, if we talk about rural and remote communities, only 40.8% of Canadians do have this access, right? So that means within Canada, we have a digital divide. which is improved in 2022, and this number now increased in a much better state compared to what we had in 2019. It is now 53.4%. Again, from the Canadian perspective, we have major roads in Canada which are without LTE connectivity, or we have communities which are satellite dependent. Right now, in the context of Pakistan, according to Pakistan Telecommunication Authority, what we call is broadband. We call broadband as a data rate which is greater than 56 kilobits per second. Now, at one side, we are talking about applications like holography, virtual reality, augmented reality application, and on the other side, we are having broadband, which is 256 kilobits per second, right? So according to this, we have 110 million broadband subscribers in Pakistan, which is good, but this number, this number is not good to support a bunch of applications which are coming in, right? Now, in 2022, I found this document on the IEEE website that they are saying with the technology advancements, we are looking for the need to revise the broadband application and do it to 256 kilobits per second to 4 megabits per second, right? So still, I mean, at one side in Canada, we are talking about 50 megabits per second downloads, and here if we are talking about 4 megabits per second, there is a digital divide, and the goal is to remove this digital divide. Now, this is one of the motivations of the 6G networks. 6G networks is more about the societal and environmental benefits, right? So one of the objectives of 6G is to support SDGs, United Nations SDGs, which they provided to support the world. So by providing better connectivity, what we are doing is whoever is sitting wherever, they can have a good access or excellent education at their house by having a better connectivity. No one sitting in the remote or rural communities will be deprived because they are sitting in those communities, right? So the objective is to provide connectivity all the time and everywhere, provide services which are based on the customer requirement, and at the same time, we enhance the values from the operational perspective. So here are the requirements for future wireless networks, that means 6G networks. So in 5G, as I mentioned, that the objective was on the high data rate, objective was on the to accommodate a large number of devices, massive connectivity, and ultra reliable and low latency communication. But here in 6G networks, we're talking more about extreme coverage. Extreme coverage means we want to, the objective is to provide connectivity all the time and everywhere, right? Connectivity all the time and everywhere. So that means everywhere means new coverage areas should be explored, sky and space, and this connectivity should be seamless. That means from end user perspective, they should not care about which technology we are using, which services we are using, they should just have connectivity, right? And another target for the 6G network is extreme low energy and cost. So we are talking about very ambitious objective, but we are talking about the battery-free device, right? We want our devices to be wirelessly charged, and we do not need to charge our device. So 6G networks are expected to connect billions of devices, including IoT, including cellular subscribers and broadband services. And 6G networks needs to bring reliable services, high performance in a sustainable as well as secure way, right? We need to provide all these things with security. Okay. So now I will briefly share some enabling technologies, which technologies we are exploring to basically complete this objective of 6G. So first thing is aerial networks. So aerial networks mean we want to integrate our traditional landline cellular networks with the aerial networks. So in case of some disaster where there is no communication through the base station, we can deploy our aerial base stations and still provide connectivity, right? So these aerial communication platforms are not only used for the communication perspective, but they can be used in future from the computing perspective. They can perform some computing tasks. That means if they are collecting some data from the disaster situation, they can do some computation, and based on the computation, they can take some action as well. Right? And they provide high mobility, increased flexibility, and main application of aerial networks or aerial communication is public safety networks. Then another enabling technology is multiple access. Now, in the multiple access case, spectrum where we have wireless communication in the network, we cannot generate the spectrum, so we need to share the spectrum, right? We need to share the spectrum. So we need to see the multiple access techniques, how we can use our spectrum efficiently so that we can accommodate as many devices as possible, right? So few technologies which were explored in the 5G networks were NOMA was one of them, non-orthogonal multiple access. Previously, until 4G, we were talking about orthogonal frequency division multiple access, and now we are talking about right, to accommodate more and more. Another thing is, if we look at the chart of spectrum management from the spectrum management perspective, see that a bunch of spectrum is under, right? So one way to look at the spectrum is to utilize spectrum efficiently, make the primary users as well as the secondary users, and secondary users can access the spectrum opportunistically, right? So we do not need to look at technologies to accommodate more and more users. We need to be we need to come up with some novel solutions as well to use the underutilized spectrum as well. And AI becomes an effective enabler to support dynamic spectrum management. Within multiple access technologies to provide security, one way to look at it is blockchain-based wireless access and networking. So blockchain is a technology which can provide us basically more security, but at the same time, it is a little heavy on the network as well. So at one side, the challenges are unique. At one side, we are talking about source constrained devices. At the other side, we are talking about some heavy elements, right? So we need to create a balance, and depending on application, we need to choose one of them. There are some other enabling technologies, for example, backhaul, fronthaul, networking and communication, quantum communication, network intelligence, machine learning for communication. We have reconfigurable intelligent surfaces and as well as integrated sensing and communication. So I'm not going into the details of these technologies since we have limited time, but we can always discuss about them. Now, some paradigm shifts in 6G networks, what we are looking at. First thing is we are talking about integrated networks. We are not talking about only cellular networks on the ground. We are talking about the integrated networks that space, air, ground, sea integrated networks. Right. So we recently submitted a paper on integrated networks. So this figure is from that. So there are some unique issues, although it looks very good. Idea that we can have a seamless connectivity wherever we go, but the challenges are also unique. We need some efficient resource optimization. We need, because every technology has their own resources. So how to manage these resources is a key challenge. Then routing strategies, which technology will be forwarded later, which one is a key challenge, and then energy efficiency for sure is a key challenge. So basically what we are looking at in future is we are looking at holistic architecture we propose this holistic architecture where we have ground network, we have our aerial network, we have balloons, we have satellite as well as sea network. Now, if we look at just from the channel perspective, when we look at the technical terms, look at the channel modeling, right? So channel modeling for all these networks or core networks is completely different. For example, in the sea communication, sea communication, the wavelength of the waves can significantly impact the channel quality, right? Which is not here in antenna, right? So we need to look at these challenges and how we can deal with the different communication channels and still provide a seamless experience. So first of all, in this case, we are talking about heterogeneous multi-connectivity enabled environment. Then we are talking about until now what we have is we have cell-based architecture. That means we have one cellular base station installed in a data and all devices are connected to that. Now we are talking about cell-free network, right? Cell-free network. We do not need these this puts a lot of limitation. We are talking about on-demand network, as I said, the aerial networks, and in addition, we want our networks to be self-sustainable. Self-sustainable means we should not be worried about charging and energy. Now, to take full advantage of 6G network, until now, what we are doing in terms of resource management, people who are working, first of all, we can divide our resources in the network into 4 key categories: communication resources, computing resources, caching resources, and control resources, right? So the research going on in this direction is people who are working in the communication area, they are optimizing communication, right? People who are working in computing area, they are optimizing computing resources, or so on and so forth. We have research done where we did that. Where we consider 2 of them jointly, for example, communication and computing resources jointly. But my point is, in order to take full advantage of the network, we need to consider all these resources and all the parameters simultaneously and then optimize to take full advantage of. So this is called 4C resource management. 4C for C for communication, computing, caching, and control. Then we are talking about network intelligence. Network intelligence, we want our networks to be, as I said, we want our networks to be self-sustainable. At the same time, we want our networks to be intelligent. Intelligent in a way that our network should learn about the environment by itself, that how many users are here, how the number of users are changing in the environment, how the channel is changing in the environment, and based on that, we learn and provide better service, right? And again, with the advances in machine learning and AI, we can explore this area and provide network intelligence in over 16 networks. And one more paradigm shift is in terms of spectrum, we are also looking at integrated spectrum. Integrated spectrum means now we are exploring, for the communication purposes, we are exploring millimeter waves. Millimeter waves have a bunch of bandwidth available, but the challenge is they are not good for the outdoor communications. Right? So we need to explore the application area where we can use spectrum, where we have a bunch of bandwidth available. We can maybe use it for the indoor communication and for outdoor we can use it for right? So again, the solution is for end user perspective, I should not be worried about which spectrum I am operating, which one I am operating, right? Whether it's millimeter wave, terahertz waves, optical communication, or sub-6 gigahertz communication. And we want to explore machine learning algorithms to better manage this spectrum in a single. Okay, so just to give you overview, most of the paradigm shift which I mentioned, we are working on those areas, but just to summarize what we are doing in my research. I have a research group where we have 2 postdocs, 2 PhD students, and 2 master students, and 6 students are here in my research group. And what we are doing is we are exploring 6 resource management areas. Particularly, we are focusing on the massive resource constrained devices, the computation limited device, energy limited device, how we can accommodate them in our. At the same time, we are exploring the diverse variety of service requirements. That every application, for example, one application may be video application and we need very high data. Another application is about smart metrics where we need a very small amount of data, and very often we need to transfer small amount. And we are considering a high density of heterogeneous devices while exploring these resource management schemes. So we are developing resource management schemes with constraints on connectivity, quality of service requirements, and coverage. And the end objective is the same what I explained before in the 60 networks, is to provide coverage everywhere and all the time. That is to contribute towards that objective. Right? So in summary, connectivity will impact every aspect of life and future economy directly or indirectly. We need to remove the digital divide, right, in order to make this world better. We need intelligent and end-to-end optimized wireless networks which are capable to handle the billions of IoT devices. And from end user perspective, they should not be aware about the system settings. They should only have a better communication. They should only be focused on technical connectivity or not that. They should not be aware of which spectrum, which technology, which area we are talking about, right? So they should not be aware of the system settings. So that's all from my side. I would be happy to take questions.
Ladies and gentlemen, if anyone is willing to ask any queries from Dr. Walid Ijaz, they're free to ask now.
Assalam. Thank you very much for a very comprehensive talk. I just wanted to have you comments on a couple of things. For example, that aerial network, the aerial vehicle, the limitation of its battery capacity or endurance. That's one of the biggest issues in drones, even with fixed wing drone. So what are your comments about that? And I also heard during your introduction that you're also working power harvesting. So are you employing any kind of harvesting to increase endurance of those drones?
Your first question is about the bandwidth limitations, battery limitations. Okay, battery limitations of aerial networks. For sure, this is one of the challenge for the aerial networks when we go for the ground. That's the reason why I mentioned that the key application is the public safety, right? Until now, we are considering this only for the public safety application. So we can consider that, okay, there is a challenge of battery, but we can deploy them. And your second part of question was?
I heard during your introduction
Energy
that you're
harvesting.
also working on power harvesting.
Energy harvesting. Yeah. Okay. So energy harvesting is one of the area that, so what we are, as I mentioned in the 60 networks, is one of the very ambitious target is to have battery-free devices. That means we harvest energy and use them for the communication and computing. So one opportunity is there that, for example, in a disaster scenario where people do not have connectivity and they may be running not only people, but some sensors which are running out of the battery power as well. Again, this is a challenge that UAVs or drones, they themselves have limited power, but we can use them in the public safety settings where they can go and charge those sensors as well. Because at that time, the key is to collect the data from that area, right? Challenges are there. All of us need to work in that direction, but for now, our application is restricted to public safety only.
I am Dr. Karachi. Last year, and restriction by avoiding overlapping and noise factors.
Sorry, I didn't get your question.
The multiple access, what can improve the connectivity between source and destination without avoiding the overlapping and noise?
In multiple access, how to
Improve connectivity.
can you adjust the voice a little bit? It's not clear to me.
My question is that how can you improve the connectivity in the case of multiple access? Without providing the noise and overlapping. No understand menu. In the multiple access.
Oh, I think without mic it's better. I can understand without mic. Yeah, multiple access. If you're separating with noise, what do you mean by separating with noise? If we have overlap in spectrum. Okay. So one way to look at this, if we have overlap in spectrum, like I mentioned in the spectrum management or cognitive radio technology, if we talk about, one way is one communication technology, we can consider it as a primary technology, and the other one, we can consider it as a secondary technology. And we want to keep the power of secondary technology lower so that we do not interfere with the primary technology. If you want to operate on high power as a secondary technology, you need to sense the spectrum and you need to wait until the primary user is not there, right? So this is one way to operate in an overlapping channel. Did I answer your question? Yeah. Noise effect. Now, noise is not only related with multiple access. Noise, in order to remove the noise, we have traditional digital communication algorithms as well. And noise, we need to look from the multiple access perspective. I would say the noise, if we are talking about noise, noise could come from the different users in the network, right? Or it could come from the channel noise as well. So if we are talking about the channel noise, that means channel noise, we need to deal with the separate algorithms. If we are talking about with the interference coming from the other users, that, as I said, that we need to put a constraint that, okay, no one should speak more than this power so that we do not have interference among the users, right? From the noise perspective, if we are talking about noise from the circuit, noise from the channel conditions, that is to deal with the digital communication algorithm. Yeah. No, that is already there. Noise is a random process. We are doing it from first generation of the networks. And for example, for the first generation of networks, we had analog communication, right? And in analog communication, it's I mean, if we remove the noise and amplify the signal, the noise will be amplified along with it. With the digital communication systems, we did one improvement. What we did is we can regenerate the signal again at the receiver side, right? It is a random process. The algorithms exist, but for now, at this time in the 6G networks, multiple access times, what I mean is that the noise from the channel is an issue, but we are talking about the efficient utilization of spectrum. We are talking about accommodating multiple users on the same band. That is more of an interference, right? That is more of an interference. So we need to devise algorithms for that. We need to devise, I know, if I talk about cognitive radio, it is time-consuming process. That means we need to sense the spectrum, and based on the sensing result, we need to operate. So yes, we need to deal with these things. Yeah, but in digital communication, when we regenerate our signals at the receiver side, that means effectively we are removing the noise with the regeneration, right? Okay.
Thank you very much, Dr. Waleed Ejaz, for sharing your valuable work on IoT and 5G technologies.
Okay, I will take your question in the break. Thank you.
Now, I would like to call our second plenary speaker of the event, Dr. Arsalan Javed. He did his MS from Linköping University, Sweden, and completed his PhD from Bruno Kessler Foundation, Trento, Italy. In 2014, he joined KIET and started the Electronic Devices, Circuits, and Systems Research Group. Under the supervision of Dr. Arsalan Javed, the EdCast group has indigenously designed 8 microchips in last 8 years in collaboration with reputed local and international funding agencies and partners such as KAC-ST Saudia, UAE University Al Ain, Ohio State University, Ignite Technology Fund, and National Centers of AI and Robotics. EdCast Group has won several research fundings since 8 years, with a number of published and patented designs related to biomedical, structural health monitoring, and wireless power transfer applications, with a paradigm-changing blend of AI-enabled hardware at the front end of electronic systems. Dr. Arsalan is currently the HOD Avionics at KIET and the Director of Electronic Devices, Circuits, and Systems Research Group. Ladies and gentlemen, please welcome Dr. Arsalan Javed.
Assalamu alaikum, and thank you very much for a very detailed introduction. So my name is Arsalan. I'm a professor here at the Host Institute, heading the avionics department, and it's an honor to be here and to have the opportunity to talk about the role of academia in a particular and a very peculiar field of microchip design. So this is going to be a pseudo-technical talk in which I would be presenting certain facts as food for thought and try to, let's say, invigorate your thought process, and also to build up certain amount of confidence, showing whatever different types of progress has been taken place in academic sector in Pakistan so far. Okay, so in next 30 minutes, inshallah, let's talk about what actually are microchips, what are integrated circuits, how they have evolved, and how they've impacted our lives. And if that looks cool enough, after looking at that, then how can we actually get involved with that? What is the required design cycle to get into that sort of design process? And then once we see the design cycle, why operate from under an academic umbrella to actually achieve that objective that perhaps we establish in the first couple of steps? And then obviously, after looking at that, we are going to have a few examples for 3 different sectors, like strategic, medical, and the industrial sector. So these are 3 different sectors that many academic pockets of microchip design in Pakistan are actually touching. So I would be presenting just quick examples of that, and then we will be concluding the talk. So what actually is a microchip. So it's the name, as the name says, it's a micro dimension piece of a silicon wafer, and it's there to have integrated circuits on it. So the next question is, what actually is an integrated circuit? So a circuit that is inherently miniaturized, it has a very small feature size, which can enable a very large scale of integration of that circuit, which means that putting a lot of circuit elements in a very small space. So that enables VLSI, very large scale integration, ultra large scale integration, giga level large scale integration. So that is an integrated circuit. So if you look at these two graphs down here, which I'm not so sure it is very clear. So this shows how many integrated circuits have been shipped since 2009 to 2022. Here, I think it's not very clear. In 2022, it's almost 500 billion integrated circuits have been shipped in 2022. Here, if you look at this, this is the cost. So it's almost the overall market of microchips or integrated circuits is $500 billion as well. So it's the same term. So which also points out to the fact that if you manufacture these rather expensive and high-tech circuits, they are dirt cheap. So as you can see that almost the cost is $1 per microchip. So obviously there are certain high-end, certain low-end microchips as well. But if we just look at it from an average basis, so how they have evolved and how they have impacted us. So for example, the first computer that was made back in 1946, ENIAC, it was just made to add a couple of numbers. It was as large as this room. When they used to turn it on, the electricity in Philadelphia used to, they used to have this, the lights used to go dim. It was dysfunctional for almost 80% of the time because one of the components would just go bad. So this is where this started from. And right now, if you put 7 basmati rice together, so that comes up with almost an area of 240 millimeters square. That's the area of your Intel processor single core. So in that, you have 1 billion transistors, 1 billion functional components operating at a speed of more than 1 gigahertz. So they're taking more than 1 billion times 1 billion things. So that is a huge amount of computational power. And you have seen its manifestation as very powerful smart devices in the form of smartphones. Sometimes, we ignore the enormity in these numbers. So 1 billion is such a large number that if somebody is born and he's getting 1 rupee in his account every second, so he would take 32 years to become a billionaire. It's such a huge number. So you have so many functional components in one single chip, which is as small as this, and they're doing something for you billion times in 1 second. This is something that we are already, I think almost all of us would be aware of. So a few decades back, we used to have few MBs in the same cost, the same footprint. And then now we have terabytes, couple of thousands of rupees, and in the same footprint. So we have come from megabytes, terabytes, that's orders of magnitude that has become possible because of miniaturization of the technology. So what is miniaturization in electronics? What is the main workhorse? So the main workhorse is a MOSFET transistor. So it's a field effect transistor. And the simplified structure is there is a source, there is a drain, and there is a controlling gate. So the whole thing that happens in electronics is that you just have to move charge from this point to this point, and that's it. So if you spend lower cost in moving a larger amount of charge, you get amplification. Otherwise, you get switch, etc., etc. What's going on in overall sense? You're moving charge from this point to this point. So if you want to make faster devices, you want to include more devices in the same area, you just have to reduce the size between these two terminals, which is called a constant field scaling of the transistor. And how do you achieve that? You achieve it through better controlled manufacturing processes, lithography processes. So these devices have been scaling for last 5-6 decades. and it's a bit, funny, but the founder of Intel actually predicted this in 1965, that this scaling would continue by saying that there's a lot of room at the bottom. So this scaling would continue, and the scaling is going down right now. Apple and Intel are making devices that are the distance between these two terminals is as small as 6 nanometers. So that's a very, very small distance. So this is one of the trend of miniaturization that's enabling your high density digital integration. Stuff that Dr. Waleed also talked about. So that's another kind of component feature set that's required now within the chips. We're talking about analog, RF, switches, passives, high power, communication subsets of the devices. So this is another direction of miniaturization. When you combine these two directions of miniaturization in a system on chip or a single system in package, so you come up with a higher value system that contains a lot of different elements with high density digital processing, and then specialized analog components as well. So, okay, if at this point, let's say if we feel convinced that, okay, this is a cool technology and let's go forward, let's do something about it. So let's look at the design side. So there are 3 main processes involved. Obviously, we are going to need to have some people who are skilled in it, and they need to sit down somewhere and they have to design microchip using CAT tools. So it's not something that you start manufacturing it. You have to design it in very specialized CAT tools, and you have to establish this holy trinity right at the start. So this starts from skilled manpower. Only a couple of EDA vendors are there in the world who makes specific IC design tools, and if you're interested, you can visit our design center. We have one of those tools here. So you have those CAT tools, and then you need to have a relationship with those specialized manufacturing facilities that are actually going to make nanometer devices for you. So those we call as fabs. So you establish this holy trinity, you designed it, you send it out for manufacturing, the chip comes back. So you're here. You followed a design process, you're here. It's an untested chip. Unfortunately, a lot of people think that's the end of the process. Actually, this is just 30% of the effort. 70% of the effort actually is taken by this testing of the chip. This is still, you're sitting inside your lab still. So you haven't gone to the field. 70% of the effort is taken by this. And then finally, you have a qualified chip that has been proven to work inside your chip. Okay, fine. So there is a very, very active debate in Pakistan that perhaps we should have a manufacturing plant for a microchip of our own. So strategic departments like NESCOM, I have worked with them. They were very seriously pursuing older feature sizes, larger feature sizes like 500 nanometers, etc. So this is a big shot. Actually, for example, a 45 nanometer manufacturing facility is going to just the installation cost is more than $1 billion. And then obviously the expertise required and the operational cost. For example, one of the interesting things with the strategic sector that I work with is the chemicals, the recipe that was optimized for the manufacturing. The chemicals that they bought, they got expired. And the recipes were actually optimized on expired chemicals. So whenever they used to buy the new chemicals, the recipes used to fail. So those are very, different ground realities within Pakistani technical sphere. So this is something that is going to be complicated. So what is the development model? How to avoid this such a large cost burden? Something called fabless or fablite. So you don't go for manufacturing yourself anyway. Even Intel doesn't do it. So there are specialized people. Far East, Taiwan is the world's top fab. So you design it, you fablessly design it, you do this, and then you send it to them, and you get it manufactured by them, and then you test the chip yourself in your lab. Okay, so we see the design cycle. So why operate from under an academic umbrella? So one of the things that I experienced myself when I was working with a Silicon Valley company back in 2012, I had almost $1 million of funding, and I was asked to make a small group of like 70 designers. I went around, I took tests in LUMS, UETs, etc. Couldn't find more than 5 people who qualified the test, and this was in. There's a huge disconnect between the electronics curriculum and the required knowledge base and the skills eventually. So obviously nobody has the tool, nobody knows the CAD tool. So that's a different skill set. However, the theoretical concepts, they're also not being taught, and we are being taught 30, 40 years older junction technologies. So this is a very well-known fact now. And the solution actually lies from within the academic institute. So that's why you have to sit under the umbrella of an academic institute. Also, it's a pretty complicated field with a longer design cycle. You have to convince people at younger ages to get involved in this. It's going to be more complicated to hire someone who has worked in relatively shorter design cycle fields. Okay, this is another big hurdle. So for example, I bought one commercial license back in 2012, and that's, I think, the only purchase of commercial license that has taken place in Pakistan so far. $14 million. One single license, $14 million. End of the story. You can't just afford it. Educational licenses, $25,000. Okay, so we have a license valid for 99 years. We paid $40,000, and that's for 30 nodes. So 30 people can work that. So this becomes possible again. I mean, paying $30,000 with the help of funding agency is still possible. Having $14 million, that's just, you can't even start the game. Okay, so again, the problem is we did one full wafer production with NESCOM, and it costed us almost $0.1 million. Again, a university cannot afford. So for universities, there are things called multi-project wafer. So these are very low cost manufacturing facilities that are available for universities. So again, you can use the literature that is available academically, which you can't use while working on commercial products because of the IP rights issues. So based on all these facts, academia is a good place to start working on this field. Okay, so now the question comes that, are there already some people? Actually, there are 4 or 5 main groups that are working on this. So okay, sorry. So this is just a glimpse of our own design center back here. Please feel free to visit it anytime during these next couple of days. Our group, for example, has been successfully, alhamdulillah, able to achieve this inner circle. We have been able to train the EHR using KIET's infrastructure, using KIET's students and its faculty. So it's a positive entanglement of research and teaching. Then we were able to come up with computing resources and the lab equipment, etc., through the support of institute and also through different research funding as well, because we have been able to generate a research funding of almost 150 million rupees in last 8 years. So this is just a glimpse. These are the 9 LCs that we have fabricated while sitting here in this institute during the last 8 years. So if you look at it, it's almost on average, it's almost 1 IC per year, right? So this hasn't happened in any other academic institute in Pakistan. It hasn't happened in LUMS, hasn't happened in NUS. So this is something that's happening here. Okay, so I just show this graph. There are a lot of details just to highlight a couple of details here. For example, this is the time when the group started. A lot of people promised us, NESCOM, American Silicon Valley based company, Open Silicon, promised us projects, nothing came. So we had to come up with a way to survive and then keep going forward with this idea. We started working with Saudis. Saudis promised us Yemen Jung started, came down again, pretty depressing. Saudis told us, told about us to UAE. We did a couple of chips for UAE. After those 4 chips, couple of chips for Saudis, couple of chips for UAE, we got contacted by Ignite from under Ministry of Telecom, and then we were able to convince them to give us a relatively longer term funding. So what I just want to highlight here is that if you want to keep a research group afloat, if you want to keep it sustainable, you need to keep multiple projects in pipeline strategically placed. Otherwise, it's not very easy for a research group in a peculiar field with a longer design cycle to survive. So a quick glimpses. These are the IPs that we designed for foreign partners. So the group started with service projects. So they wanted us to do this, we did this. They wanted us to do this, we did that. So these were the IPs, smaller portion of larger ICs. They're called IPs. So we did that, did it for them. Saudis, UAE, Americans, even Air Force Research Lab project was all done through this. We reached this point finally. So we were able to convince Ministry of Telecom, Ignite, National Technology Fund. We showed them the previous microchips and we were able to convince them to give us a relatively larger fund for 3 years so that we can develop a relatively stable infrastructure and go in one particular direction, in one particular technical direction. So in this microchip, we convinced them to allow us to place 3 different types of sensors for 3 different applications. One was for our Saudi partner. They wanted to monitor their water pipeline and we are still working with them. So they wanted to monitor their water pipeline using vibration signature. And a couple of other technologies were our own ideas, and we're going to show just a few glimpses of those later on. So this was something that we did for, and that's why I was asking Dr. Waleed as well, and I hope to have a chat with him. This was chip-to-chip wireless power transfer. This was a microchip that we did for UAE, Al-Ain University, and this was chip-to-chip milliwatt power transfer. This is the project that we presented to HEC, and we convinced them that we can transfer wirelessly almost 5 watt of power for the recharging of mobile devices at a distance of a couple of meters. So this is the setup, and most welcome. You can drop by. We can show you the overall setup. So one of the technologies from previous chips got translated into ultraviolet detection sensor for bogey detection during broad daylight for aeronautical complex. We are working on a biosensor device. We are going to just talk about it after a couple of slides. And then, yes, these are a couple of biosensing devices. So we're going to just talk about. So that was just an overview what our group is doing, just to give you sort of confidence that, okay, it is possible to sustainably go forward. This is another prominent group from Islam. This is Dr. Ashir Ramzan from FAST, RFICS. They were being highly supported by NECOP, the recent initiative that has just spun off from NESCOM. So they're supported by them. Now they're working collaboratively with Oman government for training their engineers in microchip design. So this is perhaps the oldest and perhaps the most mature setup with a lot of resources. However, they're going through a lull period right now in NED, the Electronic Design Center. Dr. Hashim, Dr. Fahim, Ms. Sadia. So they have also taped out these microchips. This is a meteoric rise. I hope that Dr. Ali is here. So since RISC-V has come up, Dr. Ali has been riding that tide quite effectively, and he has made these microchips in UID. Even President of Pakistan was there when this was inaugurated last year. So so this is LUMS. They're doing in working in stealth mode. However, they're doing very effective work in biomedical domain. So this is the National Institute of Electronics. They have the mandate from Ministry of Science and Technology. These are the guys who have the labs, who have the PCB facility, who have the funding, who have everything, and the mandate for most. So these are the guys. Unfortunately, they haven't been able to find good people to actually start designing their microchips. So right now they have started hiring pretty good people. So we recently signed an MOU with them a couple of months back. So okay. So okay, yes, there are these academic pockets there. How can they be even relevant for doing, something that could be good for any kind of industry, or strategic sector, or even medical devices. So let's start from a few quick examples from the strategic sector. So before going there, let's just briefly look at the academic and strategic model combination that a lot of companies have, a lot of countries have actually employed. So DARPA, the Advanced Research Project Agency from US, it has a dedicated microelectronics program, JUMP, University Microelectronics Program. So these are the most prominent university research labs. Otherwise, DARPA is actually quite famous in implementing that model in which they employ universities and the faculty members in an effective manner to achieve whatever the R&D objectives are. NESCOM has followed the same model. This fellowship program, they're strongly connected with a lot of universities. Recently, we just trained 13 of their employees, and they just went back this May 2022. So we are also hoping to for this collaboration to go forward. This is Chinese Academy of Sciences, very strongly connected with a lot of universities, and again the same model: engage faculty members from universities to carry forward a cutting edge R&D. Okay, so that's the strategic and academic connection. What's happening in Romania and what's happening in Lithuania? So Romania, just 10 years back, it was just known for Dracula and it was known for gypsies. Right now, it is the second largest hub of startups, just followed by Lithuania. So what has happened there, that in Europe, these countries are like 25% younger people, and they were so late in actually implementing the connectivity that they have laid down fiber optics all throughout the country. So they were late. It was a bad thing, but it turned out good to be for them. And they have fiber connectivity, very high bandwidth, and they're younger people. So they're booming, ecosystems for startup. So yeah, being late in something or behind in something actually is not always bad. I just wanted to show here. Okay, so the first thing that the academic strategic connection here in Pakistan is working extensively on is driven by the hardware spyware syndrome. So the strategic sector thinks that there is a spyware in the hardware. And now this is something that you can't really get rid of. And it's not just a fictitious story. So I've just, blurred the names here. However, one very prominent country spied on another prominent country using a chip as small as this placed in a system here. And they really spied on a lot of corporate and different strategic data as well. So that's actually happening. This is driving one of the major development being led by NICOP, UIT. We also did a couple of designs for them for dedicated digital processors that are locally indigenously designed. This is being, also facilitated by the rise of RISC-V architecture as well. So just an example how these things are happening, and similar things can be taken forward as well. So another academic strategic connection is that this is a night vision microchip that we did for NESCOM. So the problem is how to get all these expensive sensor systems. So this is a cryogenic chip. This was supposed to work at minus 200 degrees centigrade. So getting this chip is like $0.4 million. The whole system, not just the chip. So that's $0.4 million. That's quite. We made it for like $40,000. This chip was. This is actually being also part of a strategic system that was delivered back in 2014. So again, F-35 Lightning, it has its own predictive maintenance, prognosis, and maintenance system. So it has multiple sensors embedded in the body. It's expensive to get those sensors. The strategic sector wants to make it ourselves. So just a couple of examples that a connection is there and it can scale up. Okay, so that was strategic. Sometimes it trickles down and does affect our quality of life and improves it. However, let's talk about medical sector, which actually directly affects our quality of life. So let's try to explore the area where we try to take diagnostic tests out of the diagnostic labs. That's one of the major issues, and that's let me try to establish the issues based on 5 scenarios that we see in our daily life. So for example, somebody has flu, fever, sore throat, couple of days have passed. Now there is a confusion. Okay, is it viral or is it bacterial? So the confusion starts, and the general practice in Pakistan is that, okay, let's be safe and let's take antibiotic. And we haven't done culture, so we are not so sure what kind of antibiotic. Let's go for a broad spectrum antibiotic. So what this broad spectrum does is that perhaps it was targeted for this. However, the germ was this, so it doesn't kill it completely, just only makes it stronger. So the misuse of this antibiotic, this has brought us to a scenario where Pakistan is among those 5 countries in the whole world where we have got XDR bacterial strains. So those are extensively drug-resistant bacterial strains. So what's happening? They're not dying with bacteria. 70% of the XDR, Salmonella, typhoid cases are actually from Karachi, and it's waterborne. It happens during the rainy season. So that's pretty bad news. It's something not to catch, really. Okay, so the second scenario, you have just visited somebody in hospital and you acquired an infection from the hospital. So that's called HAI, hospital acquired infection. Actually, it's there's 1 0 missing here. It's almost 0.8 million. So it's more people than all these 3 combined. So the ratio in Pakistan of getting an HAI is almost 17%. So you visited somebody in the hospital and there is a big chance 1/5, every 5th person is going to be infected by infection there, because there was nobody who was biologically monitoring the environment, or there was some air conditioning going on. There was no quality checks for biological biomarkers and that. So the third scenario. Okay, so okay, so the third scenario is, let me speed it up. So it's just an innocent pool party at your home. You just put in, inflated a pool for your kids, you put in some water, and now you're not so sure that it's time for Naglaria in Karachi or not. So the Naglaria, the survival rate even in developed countries is less than 10%. So that's again something not to catch. So that's again something to detect and then avoid. So you can't really cure it. So again, these cases are very common in Karachi. So antiviral drugs, they're only effective when you give it during the first couple of days of the infection. So again, early detection, a microchip can do that. Again, POCT devices, so glucometers and things like that. Just imagine that people are actually talking about immunity passport sort of devices where actually you wake up, you check yourself if you have COVID or not. If you're okay, you go to the office. Otherwise, you stay home. Okay. So these 5 scenarios, they actually lead us to come up with a microchip that can actually detect different types of germs in real time in point of care setting. So this was our first attempt. Again, giving you confidence that this has already been done in our lab. So this was our microchip, and we had a couple of structures. These were the results. Some certain germs were successfully detected. Okay, this is our second attempt. So we are trying to come up with a glucometer sort of device powered by an artificial intelligent backend server. This is a generic device that can be tuned to detect different types of germs. So this is something that is under clinical trial right now, and we are also pushing forward for its commercialization. This is the form factor of this device. Okay, this is the next dream that we have. So sweat is being considered as the new blood. So you don't have to now to get all the biomarkers, you have it in sweat. So just imagine that if you have a patch powered by microchips, immense power. So, and then you can detect different types of biomarkers, sugar, electrolytes, different types of metabolites, and even cortisol, stress, etc., etc. Okay, so perhaps we can skip this part. We can come to this part. Okay, so we have seen, okay, we have got different setups. We've got academic prototypes ready. Now what? So now this actually is sitting here. And now you're at one edge of this chasm. So there is a huge gap. No funding agency supports you here. They just give you support till here. Want to cross this chasm and come up with a microchip that is actually commercially feasible. There is a lot of support that is required from the industrial, medical, the strategic partners. A lot of market study is needed, and this is going to also require longer term support from funding agencies as well. Okay, so the conclusion is that IC design technology is almost the mother of all the systems that you see now. So many academic pockets are actually doing relevant stuff. They have established the challenging infrastructure that I mentioned at the start. So they have been successfully able to establish that. It is being attempted. Crossing the chasm is being attempted, although not very good results are coming, because that is a good challenge to have. So this is being attempted finally for the first time from academic institutes. Promising outcomes, support from institutes, funding agencies, and all the involved partners is obviously going to be the key factor in there. Okay, thanks a lot, and please feel free to visit our design center, second floor, Avionics building. Thanks.
Thank you very much, Dr. Aslan Javed, for your valuable insight into the topic. Now, I would be honored to give a brief introduction of our chief guest for the day, Dr. Ishrat Hussain. Dr. Ishrat Hussain is a Pakistani banker and economist, formerly worked as an advisor to the Prime Minister on institutional reforms and austerity with the status of Federal Minister. In the capacity, he also served as a member of National Economic Council, EC&EC, Economic Coordination Committee of the Cabinet, and several other cabinet committees. From 2008 to 2016, he also served as a dean and director of the Institute of Business Management. Before that, he was appointed as a governor of Pakistan Central Bank in December 1999 and continued his outstanding services till 2006. As a member of the economic management team of the government, he played a key role in the impressive economic turnaround of Pakistan. He holds not only national, but also several international honorary awards. In 2003, the President of Pakistan awarded him with Hilal-e-Imtiaz in appreciation of his remarkable contributions. The Banker magazine of London declared him as a Central Bank Governor of the Year for Asia in 2005, after which he received the Asia Banker Lifetime Achievement Award in 2006. Later in 2016, the President of Pakistan gave him the highest civilian honor, the Nishan-e-Imtiaz, in recognition of his exceptional public service. His contributions to Pakistan economic and educational systems are limitless. So without further ado, let's welcome today's chief guest, Dr. Ishrat Hussain.
Bismillah ar-Rahman ar-Rahim. President KIET, faculty members, distinguished delegates from outside Pakistan and inside Pakistan, faculty members, and dear students. First of all, let me thank the organizers of this conference for providing me this opportunity to come and share my thoughts with you. I have never refused any invitation from a school, college, or university, and I give up everything in order to come and talk to you. And that's the reason why I'm here. Let me first say how impressed I am with the quality of work which is going on at KIET. And particularly, I was very impressed by what Dr. Arsalan Javed just pointed out here. This is exactly the direction in which the world is moving. Recently, after the pandemic, the whole world realized that the microchips and the semiconductors are so essential for our daily life that the entire supply chain just got disrupted. The cars couldn't be made and other gadgets couldn't be fabricated. The shipping costs went up because there were only two sources from Taiwan and from Samsung in Korea, which fabricated these microchips. So the world has now woken up. Any country that, like the United States, decided to invest billions of dollars, although Intel has been the leader in providing the microchips, but they are now behind the SMC and the TSMC as far as the fabrication was concerned. So in the new bill, which Biden got approved by the Congress, they have allocated hundreds of billions of dollars for the fabrication of semiconductors and integrated circuits and the chips in the United States. Next door, the Indians have given what they call as a performance-linked investments in the microchips and semiconductors because they are essential. And because Apple is now going to assemble its 14 iPhone in India, all the suppliers like Foxconn, they have all moved into India in order to participate in the supply chain. So it's not only from the point of view of the economy, also from the point of view of the security, that we should try to have this technology, which is so critical and essential. And you heard from Dr. Ejaz as to how much IoT will depend upon these microchips, both for spectrum management, for the multiple access, for quality of service, for everything. So I'm very happy to note what is really happening at this institute. I was not aware. And I must also commend Dr. Javed for pointing out the work which other institutions are doing. Otherwise, we work in silos and we say everything is being done here, nothing is happening elsewhere. And so I should give him the credit that he had the courage to say, look, I'm not the only one, but there are others who are also doing the work. Now, how does the academia then translate into commercialization? And the MIT professors and the Stanford professors have proved that this can be done. Their PhD students form the nucleus of their startups. Whatever work they have done in the labs, they develop the prototypes and they commercialize. Although success is not guaranteed. The success rate of the startups is only 1, 2 in 10, but they are risk takers. So they set up their own companies and the universities very gladly allow them to get the patents in their names. And after earmarking a small amount for using the infrastructure of the institutions, they allow all the pecuniary benefits to be appropriated by the professor and his team. I have argued that this is the way you will be able to distinguish between your bright, dynamic, up-to-date faculty members who are doing things like what you have heard, and those who are dead wood, because nobody will actually care for them because they haven't contributed anything. So that incentive structure has to be moved in the direction of those who are creative, who are innovative, and who are capable of translating this into the commercial application for medical purposes, for industrial purposes. The purposes are multiple and Pakistan really needs them. So the second argument which I have been making is that like DARPA, we have the strategic plan division because the defense has really done marvelous work in Pakistan. If you look at all the advanced technologies, it is Camera, it is NASCOM, it is Pakistani defense establishments which have been taking the lead. So now we should have collaboration between them because their funding is not subject to, the kind of audit which is done in the civilians. In the civilians, you are constrained and the fear of failure is very high. So if you provide financing from the civilian organizations and you are not able to produce results, you will be in trouble. But as far as the defense is concerned, they take risk and they are very comfortable with failure because they know that science doesn't have a ready-made answers. You take a lot of work before you come to the real answer. And this is what DARPA has been able to do. And not only now they're doing it for DARPA, they're doing for health services, they're doing for other sectors in the United States, forming the same organization on the lines of the DARPA. So I would suggest that there should be greater collaboration between what Dr. Arsalan Javed is doing and our strategic plan division to begin with, and then go to the Pakistani, businessmen and try to give them the proof that this is something which they can do and they can finance it, because you cannot imagine how bad the fiscal situation of Pakistan is. We'll keep waiting if we want the government to come into the picture. So I would say that once you have done the prototype and you have shown what you have done, exhibit this to the group of businessmen. There are businessmen who are progressive minded. They're not all of them, but some of them. So the third argument is that you should extend the prototypes and show the proof to the businessmen and ask them to invest it. These are billion rupees enterprise, so you need a consortium. So why should our businessmen go and invest in real estate, billions of rupees? That is not going to do anything good for the country in the future. The future of the country lies in science, technology, engineering, and math. And this is what you are trying to do. And this will take us on the next platform. Otherwise, we will remain backward like very poor countries in the world while others are progressing. So the message to the students today, which I've been giving to all the students, is please do not chase degrees, certificates, or grades. The world is no longer interested in what your grades are or what your degrees are. They are very interested in what knowledge you have accumulated, you have assimilated, and you are able to apply to the real world problems which are facing the country. Unless you do that, you are gone. You will have no future, because today's world is not career, it is employability. And as a lot of Dr. Ejaz's and Dr. Javed's presentations show, we are having a disconnect between what you are being taught and what the requirements of our economy are. So there should be continuous interaction between the industry and the faculty in order to retool your curriculum, your pedagogical tools, your assessment methods. For example, the examinations for students of electronics or for the computing sciences are just waste of time. You should do the projects and prove that you can do this. And that is your ingenuity. That is your innovation. That shows your creativity. So that is the direction. I hope KIET, being partly collaboration with the Pakistan Air Force, which is a very fine organization, I have great admiration for them, can show the way. And then people who are actively involved should get together, because our resources, particularly human resources and financial resources, are limited. So the 5 or 6 universities together should form a consortium so that you're not actually overlapping with each other and you are not duplicating the work. So the better communication through a consortium of these institutions, in which the curriculum, the contents, the pedagogical tools, as well as the assessment methods are agreed that this is how we will produce the skilled manpower which is required for this. And this is very sophisticated manpower which is required for the next generation of technologies. It's not just the technologies we're talking about. We are talking about genetic engineering. We're talking about biotechnology. There's this complete revolution in the world. So we have to get out of the traditional mode of thinking. And I appeal to the students, and this is my consistent, please pay serious attention to the time you are in the university. Don't waste it. Don't just squander this time. Acquire those skills which will lead you to lifelong learning process, because the world is changing so rapidly. The jobs which existed 10 years ago have disappeared, and the jobs which are going to appear in 10 years, we do not know. So it's a lifelong learning process. You have to continue to invest in yourself. This is an investment in you. And at regular intervals, you should keep your minds open. At this age, I don't have a research assistant, but I produce books. I contribute chapters to the books. I write newspaper articles. I write journal articles, because I keep on acquiring new ideas and new knowledge. You can do it because you're young, you are energetic, and the future of Pakistan lies in your hands. So, Mr. President, thank you very much for providing me this opportunity. I would have stayed back, but I have another appointment. So I wish you all the best and a successful conference. Thank you.
We would request our chief guest, Dr. Ishaq Hussain, to kindly stay on the stage for presenting the souvenirs of appreciation to our guest speakers. I would also like to request President KIET, Air Vice Marshal Usaidur Rahman Usmani, Sitar Imtiaz Military, to kindly join our chief guest on stage.
First, I would like to request Dr. Walid Ejaz from Lakehead University, Canada, to kindly come on stage and receive the conference award from our chief guest. Next, I would like to request Dr. Arsalan Javed from Department of Avionics Engineering to kindly come on the stage and receive the conference souvenir from our chief guest.
Now, I would request the President KIET, Air Vice Marshal Usaidur Rahman Usmani, to kindly present a memento to our chief guest. Thank you very much, Dr. Ishaq Hussain and President KIET. Ladies and gentlemen, I would now request honorable chief guests, plenary speakers, faculty members, and our guests to kindly join us for the group photograph just outside the venue. After the group photograph, you're requested to kindly join us for the tea break of 30 minutes, after which we would resume our conference. Students and other attendees are requested to be seated till the announcement. Thank you.